And that brings us to today's session, Literate Programming and Interactive Reporting with Jupyter Notebooks by Professor Anton Babkin. Professor Babkin got his PhD in economics at UW-Madison in 2017, then completed a postdoc, and is now a research professor at the University of Connecticut. He also works remotely at the Federal Statistical Research Data Center Lab here on UW-Madison campus. Anton performs data analysis and modeling with Jupyter Notebooks as part of his day-to-day work. Today, he'll share some of the techniques he has learned with us. So with that, I'd like to hand it over to you, Anton, and you can take it away from here.
Thank you for introduction, Jane. Hello, everyone, and thank you for coming to this workshop. My name is Anton, and I'll show my face for a couple of seconds here and then pause the video when I switch the slides to save some bandwidth. If you have any questions during the workshop, you can send them into the chat. I'll try to keep an eye on it, and we'll try to answer them. So let me get started with my screen. Let me know if you don't see anything. I assume it should be working now. So in a nutshell, what I'm going to talk about today is how we can make our research work, our analysis, more dynamic, more interactive, more understandable, and also more reproducible. And there will be many different tools that I will be using here, different packages and libraries. And it might go a little bit over your head, especially if you haven't done data analysis in Python before. But just keep in mind that I think the main point here, the main takeaway is the overall workflow. So how we can use various tools and approaches to make better science. To motivate this, I want to start with this article from The Atlantic that I read in 2018. And I don't know if this streaming is showing you the animation of this burning scientific paper, but that's an image that has stuck with me since then. Basically, the point of the article is that with all the technological advancement, we're still the primary way of doing and sharing science. We're using what was invented 4 centuries ago when the scientific papers started to be published. Yes, now we are digital, we are sharing PDFs, but still this is, in my field and probably in many others, this is still the primary way to report your research findings and to share this knowledge. With the article proceeds to talk about the advancements in technology and the tools, and they first mention Wolfram Mathematica, which basically introduced this. I think it was probably one of the first to introduce this idea of interactive notebooks, and then Jupyter notebooks, or formerly IPython notebooks, as the newer iteration of that same idea. So another theme that I put in the name of my workshop is literate programming. And here's a quote from a computer scientist, Donald Knuth. I just realized I was going over my last year's slides from this from this event, and I was also using a quote from Knuth back then that was about processing bigger data. But the idea here is that we can write code that is understandable for humans. And he was addressing more software engineers, but now in most of the scientific disciplines, more and more we are programming, we're writing code. So I think this is a good advice for us to just describe in plain words, in plain English, what we're doing. And also maybe for many scientists, like in social science, I'm an economist, we maybe started our research scientific journey writing more in words than writing code. So this literate programming approach can come more natural to us than for people that are coming from the computer science and programming side. So these are the two big ideas. In this workshop, we'll be walking through steps of a small mini research project from start to finish, from getting the raw data, processing, ingesting, converting to appropriate format, doing an analysis, reporting some tables and figures, and in the end there will be an interactive dashboard then that you can host online and let other people not just read your paper and look at your figures, but try different things, try to modify your results and see how they look from a different angle. Like I said, there will be many different tools, but again, always keep in mind that the main idea here is that just the bigger picture of workflow organization. And specifically, the analysis that we'll do, we'll explore how states and counties in the United States compare in terms of their population and employment growth in the last 30 years. We'll be using data from US Census Bureau, and yeah, that's the focus. That's our toy example for today. But really, it is very similar to what I do in my actual work. Now, if we run out of time and don't get to the very end, let me just quickly preview the outcomes of this project. So first, if you follow this workflow, you will have a public repository like the one where I posted materials for this workshop, where people can use your code, can read through your results, and copy your code and build on top of it. And also they can go to issues and provide you feedback that might help you fix some problems or improve what you're doing. The next thing is that you can build a static documentation of your work. So the work is primarily a collection of notebooks, again, in a repository. Everybody can go and open and read them, but notebooks don't always look good in GitHub, and you might add some little style and maybe not show some of the parts. So for that is a website that you can host on GitHub, you can host on other places. So here it's sitting in this docs folder, and I opened it. Again, if you are trying to follow along, you can click that link. That should work for you. So this is the README file of the workshop. It becomes this front page. There are also other pages describing the data work, some preview of some of the results, description of the analysis. And even this particular tool that I'm using is building this search functionality. For example, I have Jupyter widgets in my workflow, so you can search this documentation site and jump right to a section. So that's for kind of a presentation of your results in a static way, but also another thing we can use. We can host our notebooks on a computational platform. So here, throughout this project, I'm using Binder, and this is one of the ways you can actually follow along. You can open the workshop in Binder and execute the notebooks, step through them. But also, we can host an interactive dashboard. And right now, I'm showing my local copy because I had some problems with Binder today. Maybe because all of you are trying to access that. That's a free service. They're providing computational resources. But in the end, we'll build a dashboard like this. with some controls on the left that you can dynamically update, zoom and scroll the map, click the areas, and see plots that depend on the choices. So again, I'm not very experienced in building dashboards, honestly. So this might look ugly if you've worked with dashboards in the past. But again, the point here just to illustrate the use of tools and the idea of making your research. This consists of these parts. And finally, one of the issues that I was experiencing previously is that as my projects were growing bigger, I wanted to reuse some of the components. Yes, of course, that's the bread and butter of software engineering. You write modules, you write functions. But again, if you didn't study computer science or programming, that might not come naturally to you. So here, the approach is to try as much as possible to modularize the work and turn into smaller bits. Then we can mix and match these components that also can be easily imported in Python code. So here's a short example. And the slides, of course, are built out of a Jupyter notebook. So this is a cell where I'm building a Python package called popamp, and one of the modules is called analysis. So I import that module, run a prep data function, and then generate a plot. So you can just take this 3 lines interface of your project and put it somewhere else and use in a different project or in different components of your workflow. And so now, again, a couple of words about the environment in case you are you want to follow along through the workshop. If you have a local Python content environment, that's probably the most robust and reliable, but it might, if you didn't do this before, it might be a bit challenging to make it work. But there were changes in the repository. I pushed something like an hour ago. So make sure you have the most recent copy of all the notebooks. And the easiest, of course, is just wipe out your local folder and clone again. There's the famous XKCD comic that I wanted to add, but couldn't find the link quickly to put in the slides. If you do not have a local environment, again, this was something that worked a year ago pretty well for the same workshop. There is on the GitHub homepage, there is this badge right at the top, launch binder, and that's in the setup instructions. That's the first section here using binder. Again, in theory, if you just click this link or this badge, it will open a new window, and there you will get a virtual machine that will be the entire content. The most recent version of this repository would be copied over there, but it might take time to load. It might fail to load because resources are provided when they are available. So again, your mileage may vary. All right. So now the last thing, before we get into actual notebooks and environment, an overview of the file structure. This is a big part of the project because all the parts are connected. So of course we have at the top a README, then the environment YAML. This is specifying the packages that I used in the Python packages that I used in your repository. So that's what you used if you made a local copy, and that's what binder is building on the fly when you start a binder session. mkdocs YAML is a file that is configuration for the static documentation website. Then the core really is this notebooks folder, NDS. Inside of it, collection of notebooks. I like to have some kind of a control panel notebook. Here I'm using init underscore. That is just having some high-level tasks for the project, but also There are tools, data analysis, and dashboard for different notebooks. So there are 4 parts of this project. The PopAmp folder is actually a Python package from which you can later import. And the 3 modules in this package are Python scripts that mirror the 3 notebooks. There is no module for dashboard because really dashboard is only intended for interactive use. And there is no module for init, but you could. The init file in a package is where you can expose top level interface to your package. So this becomes importable. But these files are all created automatically from a notebook. So we're only editing, changing notebooks, and this is built by the tools and utilities. Then there is a directory docs src source. So there's temporary docs files. You do not see them in the repository, but if you rebuild documentation locally, these are created, and that's just part of the documentation building pipeline. Because then they are turned into HTML website documentation. And again, these are the 3 parts: tools, data, analysis. These are 3 blocks of the project. And you've seen these 3 files. The actual files are different, but that's the main parts of the static website. So that's the file structure of the repository. Now let me go into my Jupyter. So again, I have it running locally. If you successfully get a binder session, your interface would look pretty much the same. It's kind of cool. What's cool about binder is that it creates a standardized container, and everybody's experience is the same. So let me start again. Right now, this is my repository. There are some of the folders that you might not see because they are ignored by Git, so I only have them locally. So the first thing you do to work with this repository, you initialize paths. And the most important really is because we will be working with notebooks, and because of the way the imports work in Python, in a notebook, if you want to be able to import your module in the notebook, now remember the package with modules is actually the top level PopAmp here, and here are the files. So if you want to import in the notebook, there are multiple ways. So what I'm using, I'm creating is usually when I start a project, I'm creating a symbolic link in the notebooks folder, so it's visible. But this really PopAmp that you see here, it's not a copy, it's just a link that's pointing to the top level folder with modules. But the first, if you do it for the first time, I'm here, I cd up 1 level, import, and run this command, and then cd back. You need to do it once when you made a fresh clone of the project. And this NBD is the toolbox that I've built. That is internally, it is creating some documentation folders and link to creating this symbolic link to model. So once this is done, you don't need to change the directories up and down in your notebooks. And the next thing I can do is just run this huge cell to test that the environment is working. And there's a it's using geographic data, it's using plotting, it's using some widgets. So most of the tools that we have here, again, is just to see if your environment is working, if all the packages installed correctly, and you have all the files and so on. And the last 2 sections, like I said, this is a control panel, so I don't need to do this now, but this cell I run if I need to rebuild my modules from my notebooks. And this other cell I've been running extensively today when I want to rebuild my documentation. Okay. And you can put some other tasks in this notebook. One thing that I have, for example, when I work in the RDC lab, there's a computational cluster, and there are long-running jobs that we need to submit to a scheduler. So again, this is the place where I will make a section to run different parts of my project, and I execute a cell, and the job gets submitted to a scheduler. That's another use. And like I said, the name underscore double underscore init underscore for the notebook is so that you can make a module that will be the top module of the package. So that's the setup. Now let me talk first about the tools notebook. And I can make it a bit more. Okay. So these are in these notebooks, I put together different tools that I use throughout the project and that are possibly useful outside in other projects. Again, the first section is standard Python imports. Now I'll talk about this NBD thing. This is a markdown cell, again, under the hood. This is the standard markdown. You can insert images in the cells, and they get converted, and then they are also turned into the documentation side. So the tools page looks somewhat like the notebook too. So, but the notebook is the source. So the NBD is this little toolbox that I've built, and what it does in this diagram, basically it covers almost all of it. In the middle, we have a structure of a notebook. Notebook is really just a sequence of cells, right? So you have markdown cells, code cells, back to markdown, and so on. So here, the markdown cells are in blue, code cells are in green, and also some cells will have output that have in yellow. So we have it all in the notebook, some ideas, some thoughts, some comments, some exploration, some scratch code. We just fooling around and trying things, exploring. Then once you've found some good idea, you will write a more robust production code. Then you can explain that additionally in another piece of documentation, maybe some tests, maybe give a use example, then run to produce your final results and explain it. So this all can happen in a single notebook. Now a notebook can on one hand become a Python module with the same name here in a different folder that will only have code cells, but also we can export code cells selectively. So maybe this example code is good for a notebook or scratch code, but really we don't want it to be in our module. And this also solves the problem and common criticism of Jupyter notebooks that they have this so-called hidden state. So many of the variables that you create in cells are global, and they are shared between all the cells. And cells, if you just run a notebook, you would often execute cells out of order. So this can create problems where you made a variable, changed it in one place, then forgot that you changed it, or maybe you used the wrong name and you thought you were using local variable instead of you referred to global. I've run into this millions of times, but again, that's fine as long as you have some quality control, quality check in the end. And for me, this is building a module and then running that module as a separate component. So if it fails there, then it means, okay, I messed up my global variables or something like that. On the other side, we can turn a notebook into this documentation page that most of the code is not there, but the markdown parts, again, not everything, maybe just some random ideas shouldn't go there, but some documentation, some bits of code, and some results can go to that part. So this NBD, again, later, you can go to the repository and check out the details. But basically, it does these two things. And it was greatly inspired by an NBDev package written by Jeremy Howard and others from Fast AI team, which is basically the same. It's doing the same, but much more. And I just wanted something simpler and smaller. So this, what I'm using here is just a much reduced and simplified version of NBDev. Check that out. If you like this approach, you might find that that tool to be useful. Here again, I describe in greater detail how to use this this tool, basically we would need to create an instance of an object and tell what is the package name, and then use these two methods, and nb to mod to build a module, and there's nb to doc and build docs to build the documentation side. So here comes the code, because it's a notebook. I can, well, actually, let me do that. I'll restart the kernel to make sure that there is no variables dangling in the background, that I created a variable, ran a cell, then deleted a cell, and the variable is still there. So here I'm creating a module, and here is a use example. So I'm creating an instance, and then it has also a field root that's printing my the root directory of the project. Now I want to bring your attention to this little comments here. You might have noticed them in some cells. So this is really how this idea of selectively turning notebook into a script or a document. This is how it is operationalized. This is how you make it work. You can also use cell tags. That's another approach. And so notebook, you can tag every cell. But what I'm using, I'm putting in the top of the cell this little markup. So it says NBD module. That means that this cell should go to a module. Then this, although it's marked down, you don't see, but really at the top, there's this hidden comment that is also showing that this markdown cell should go to my documentation. Same with the top cell. Then this cell where I defined the class goes to the module, of course. Then here, this is a little snippet for documentation. Again, let me show you how that works right here. So this is the same image, the same description, but then the code block is not here, but this little part is there with the output. Okay, so that's this is this approach and the tool of building a notebook turning a notebook into a script and into a document. Now, of course, this is all happening on GitHub. It's hosted on GitHub, and I'm using Git to version control my work. And unfortunately, notebooks are not very Git friendly for multiple reasons. So I've tried different approaches over time. The easiest is just to, at least if you're using notebooks with Git, at least clear the output of the cells, because every notebook is a JSON file. And the output, I want to show you an example. Let me actually, yeah, this, no, not this one, this one. All right, so notebook with cells here, there is that image in the output. So if I open the notebook as an editor, right, so this is a JSON. First, there is, aside from the code and documentation that I've written, there's a lot of extra metadata when the cell was executed and so on. Also, it's JSON, so it's not, doesn't look really good on Git diffs, and when you merge notebooks, they often break. But another thing is, okay, yeah, this is how a table looks like, and this is the ugliest part. This is a binary representation of an image in the output cell, and this is huge. This is will be clogging your history with little meaning. So at least clean the notebook outputs. But sometimes you'll forget to clean them, and you can automate that process. There are multiple utilities and approaches that can do that. So I end up using nbconvert, that's just stock component of Jupyter, and nbdime to help with merging and diffing. Again, I'll skip over details. You can later check. Another interesting approach that I haven't used, but I will certainly explore in the future, is that not store the notebooks as they are, but instead turn them into just some plain text went for Git, and then back into notebooks for work and execution. And the Jupyter project is using that approach. So again, something to check out. Then there's another miscellaneous section, and this utility notebook. I have a function to download a file that is good to automate this download process, and also good for reproducibility. And if you're hosting a dashboard somewhere, then your cloud-based dashboard needs to retrieve the data. So that's where this the function comes handy. Again, the logic is this is tagged to go into module, so I can later import it. Then here's a little example that is just showing the use, but also testing that the code works as intended. I both use here in the MVD, testing the MVD class and the download file function, and make sure that I'm downloading the license file and make sure that it is the same. And lastly, in this notebook, I'm building this notebook. I'm building a model out of a notebook. Okay, here's a code. Get my NVD. Actually, it was defined elsewhere, but sometimes I only run this single cell, and I can call an NVD to mod function that converts a notebook into a module in the library. And I want that cell in the documentation together with this header. Again, if you go to this version, it's down there. And now let me quickly go over the module file that is built out of this notebook. This is just the compact and clean Python file with this import cell, with the cell defining the NVD class, and the cell defining the download function, and that's all. Right? So it is less likely that you will define some global variable somewhere in your notebook, and your function works only because the global variable is, but as soon as you try it outside of the notebook, it breaks. So this will help you expose and fix that kind of problem. All right, so that's the tools notebook. Next, let's, once we have the tools sharp, let's actually do something with them. This next block is getting the data and the preparing for analysis. I have three major sections here: geography, population, and employment. Again, everything is with this build decorations. So the data module is built, but also I start using the module that I've built in the first notebook in the tools in this one. So I do from popam.tools import NVD and download file. So these are important from the script, from the module that I've just shown you. And again, let me get a fresh start. I'm also defining a global location for my data. The entire data folder is git ignored, so you will not get this with your repository. Again, because it's, especially for big data, it's not a good idea to store it in Git. And because this data is public, it's easy to recreate as long as you have the code. So the entire folder is git ignored, but as you go through the cells, it will slowly be populated. You will be downloading the raw files and then create these 3 pickles. This is just pandas data frames. So for geography, for geography, we want to do some map plots, and for them we need shapefiles. But also, just in this shape files that I download from the Census Bureau, there are FIPS codes for the state and county and state names that I later use to make readable labels for my plots. So that's this first part. Again, the cell itself, I'm write down what I'm doing. So literate programming. I describe where I got the data, maybe some issues with the data or some alternatives that I considered. I also here for the for the purpose of this workshop, I put in the links to the packages, so you can later go over the documentation. Yeah, so this first section defines the function geo that is downloading 2 shapefiles using the download file function from tools. It's GeoPandas is reading that and creates a geodata frame, some simple manipulation and renaming columns, putting together state and county file and make a final data frame. And another pattern that you will notice in most of these functions is that at the top, I check if the file geo.pickle exists. If it does, I immediately just read the data frame from that file and return. Just keep the work. If I want to redo this, actually, let me try that. For example, geo, I can delete the file. All right, so it's not there anymore. I can even with a CB 1211, so I can delete the state file here. Because the download function is also doing the same. It downloads, stores in disk. And if you try to download again, if the file exists, it will skip it. So let's define the function. And the next cell gives an example that goes to docs. So if I run it now, it will download the missing shapefile, and it will pop up here. And it says, oh yeah, the county zip file already exists, and it will store it to pickle, and that's the head of the table. Now, if I run this again, I just get the data frame because this first condition is checked, and the function immediately quickly returns. It still needs to read the file, but especially when you're working with bigger data, this is a way to cache the progress of your work. This is why it is important to organize your workflow into smaller functions that do small parts of work, so that you work on one function, make sure it works, and cache the results, and then later down the line you're using that function, but you don't need to repeat all the work of downloading and cleaning and processing, so it returns much faster. Okay, so that's what we have here. The final data frame is has these columns for state and county identifiers, the full name of the area, and the geometry. So just very quickly, the way Pandas works with geographic data, it's basically like GeoPandas. It is like a Pandas data frame with this additional column, geometry, that stores shapely, in this case, polygons, but it could be points or other shapes. But for states and counties, we want the boundaries of the area. So that's a geometry column. And there are a lot of functions that are under the hood. They are shapely functions, but GeoPandas is exposing them as a geodata frame interface, and that you can use to do selection, manipulation, whatnot of the geographic data. So here, just a very simple and short example. We can use in this CX accessor, we can select the shapes, the rows of the table that touch this bound between minus 120, 110 degrees latitude in Western Hemisphere. And also, I select a subset where county code is equal 000. That's the convention for states. So yeah, here I'm again calling this function. It will be quick because it will just read from disk, do the selection, and make a plot. So yeah, the data frame, just like Pandas data frames, can use matplotlib to plot series, to plot data in columns. The GeoPandas can plot the shapes in a map. Just one more comment about working with the geographic data. Familiarize yourself with the coordinate reference system. because every shapefile comes in some coordinate system, and these are, in a nutshell, these are different transformations of the coordinate system. So, for example, this one from Census comes with EPSG 4269, but we can, for example, using the GeoPandas function to CRS, we can convert it to a different system. Again, this D is the same data frame. And yeah, it's not very clear on this little part of the globe, but it has slightly different shape. Let me know if you have a better example to show the transformation. But at least you see the coordinates are different. So these are not degrees anymore. This is what's used in Google Maps, for example. All right, so that's the geographic section. Now, let's move on to population. So we want to see how population changed in the geographic areas, states, and counties over time. And for that, I use Census Population Estimates program. So that every decennial gives us the most precise numbers for population, but between decennials, they use the migration and birth and death statistics to make these estimates. It's broken into 10-year intervals. So there are 3 different functions, different cells at first, but I start with a cell, and then in the end, once it works, I wrap it in a function. So 3 cells to process these 3 parts of data. Also, I make a little note. This I remember in the past spending some time trying to decipher these older files because, well, nowadays everything pretty much is Unicode, but many of the old files are in different encoding. And back in the 90s, this was a big thing. A text file, if you get a file which is a text file, but you don't know the encoding, it can be very, very hard to figure that out. So I make a note about it in the notebook for myself, for others that happen to use this data. There's a link to the Census website that describes that in greater detail. So from this later 2 decades are simple CSV tables. So there are 2 functions to process them. And let me see. First, I define them. Again, specify the encoding, read a CSV from a downloaded file. Now, then the 90s decade is a long text file. Actually, I have it right here. I think it's this one. Yep. So it's a file that looks like this. I couldn't find a better format. Maybe there is, but just that's the best I could find, because I wanted all the years in one table, and I didn't want, all the states, all the counties. So it's really a text file with a table, big table for states and counties, and it's really huge, followed by some other tables, some text, and so on. So this function is a bit more complex. We need to do some text processing at first, which Python is really good at, and that I use the one to identify the lines of the table that I really need, and then use the pandas parser to actually make a data frame. Anyway, this might take you some time, but once you're finished, wrap all this complex logic in a function that does something useful, and you know that it works. Finally, the pop function is like a top level to construct the entire population data frame. See, it is calling these 3 other decade functions, put the data frames together, and again, checks for the pickle file if that exists. Let me delete that. So then it caches that to the file. That the file exists, but I need to rebuild it all. All right, so we got a data frame here. One thing that I noticed I haven't used this data much before. So when I was preparing this workshop, I found that, right, so this section will take the data frame and do some plots. The national total population, the population in Wisconsin, and population in the Dane County. So you can see there's some oddly looking jump between 99 and 2000. That's probably, again, because the data is in different formats. Maybe I made some mistake processing. Maybe that the methodology of what is reported in these tables changed slightly. These are not the same format tables. I don't know. And I added this question for future interested researchers because this is not really, it doesn't hurt in this project to have some data weird features. But again, I make a note of it, write in a markdown cell, and put a small snippet that makes that clear and explicit. It's also in the documentation version of the notebook. Right? Again, maybe myself in the future, maybe somebody else who works to build on top of this work, they will know that there is this little gotcha that they don't want to miss. If the employment accuracy, population accuracy is important. It's not that important for what we do today. And the last part is the employment. Here I use the business dynamic statistics program from Census Bureau. Some links, some descriptions. This was the cleanest of the three. Well, the geographic data is also pretty good, but this is just download 3 CSV files, combine them, rename the columns, and we're done. And let me try to repeat this. Find a function. I built the full data frame. It's now pickled. And here's a little demo of the data that will go into the documentation version 2. You can see this is the well-known dip around 2009, 2010, where we had a great recession in the global financial crisis. There's also a little recession after the dot-com bubble, but overall, the employment's been growing over time in all 3 areas, the national, the Wisconsin state, and the Dane County. The last thing, and I'll probably skip over this really quickly, but I promised that when I invited everybody to this workshop, I promised to talk about APIs. So here comes that. Just for what I was doing, it was the data tables were readily available as CSVs, but sometimes your data provider might not give you this like bulk download opportunity, and data is only accessible through API. Another good use case is like you're building a dashboard, interactive web app, and the full source data is really huge, but your users interacting with your dashboard will be only picking out small pieces at a time. So this is where you can use the API to dynamically get the data from the data provider. So here's a small example. Census data is also available through the API. I'm not a big fan of it. It's somewhat clunky, but you can get pretty much the same data like this BDS employment data. Here I have an example how you can retrieve the same data using API. APIs in a nutshell, you submit a HTTP request over the web and you get back a response and decode it and turn it into a table, text, or whatever it is. Very often it's in JSON format, like is the case here. For the request, you need to provide the URL, and often to customize a query, you will be using URL parameters. So it's a really long string, but what it has is the first part is the endpoint or the base URL, and what follows after the question mark are the key value pairs. Get equals this, then the end 4 equals county something, and so these are, I break them and further described here. One little hint that I want to give you is that when you're building these queries, building these URLs, instead of writing it all in code, you can just try it in your browser. I have it open here, but let me try if it just works. So you take this URL, paste it in your browser, run, and back comes the response. So it means that the query is correct. It can be very helpful when you are changing the query from a query that worked, you're trying to build something new, and it might be tricky. So it came back as a raw JSON file. I have here all the counties, Wisconsin employment over the past over 5 years, but then Firefox and Chrome probably too. I haven't checked recently, but it can render that as a JSON. So it's a list. You can see it's a list. So again, you will get the response and can explore it interactively just in the browser. But once you see it's more or less working, you can wrap it in code and use the requests library to submit. Here I construct the request.get is the function that sends the request, and then I get response back. And this is the top of this list of lists, really, that was encoded as JSON. One thing, quick note about keys. So oftentimes, API access would be protected by an access key, just to prevent spam. And census key you can get for free for census APIs. But this is, just make sure you do not share it accidentally. Like, do not hard code. Right here, I need to pass in this query string. In the end, I need to pass the key. Okay, so it's a short string, about 30 characters long in census case. But again, you don't want to put that in your code and publish it for the whole world on GitHub, for example. So instead, one approach is to have a secret file, census API here that I won't open, and read from that file. Just read that string, and this file is git ignored, so it's not pushed to GitHub when you are committing your updates. To use environment variables of the operating system. Both work fine. But again, I read it dynamically and put it into in the end, I put it in my long query string. And then, yeah, you can make a data frame. It is the same data as we got in CSVs. And the notebook ends with this section to turn a notebook into a script. I find that useful because I'm working with a notebook, making small changes, scroll to the bottom, and run this cell. Oh, actually, let me see if this section, this block works with the APIs. Request library. All right, yep, came back. So here I'm using a key. If you do it without a key, it should also work. There are some limits on how many I can do, up to 500 queries per IP address per day. So unless you're sharing with your IP with many other users, you should be fine without a key. So try that. And just making a data frame. All right, so turn the notebook in a module. It's handy to have it in the end, but also I could use my control panel notebook to build all the modules at once in one go. All right, so let me pause for a second. This concludes the second chunk of our project, the data. And we have about 20 to 30 minutes left in the workshop. So I'll go a bit quicker through I know I'm really going quickly, but like I said, don't worry about missing maybe some of the details of what's going on. Just think, keep the big picture in mind, how these all parts work together. So the next part is analysis. And we have our data ready. Maybe somebody else in your team, in your research team, is responsible for that part, and you are doing the analysis. So they prepare this module and pass it to you. You might not even know how it works, but they've given you the Python module and data.py with some of the functions exposed with all the necessary imports. Yeah, amp. pop geo. So you can just consume that in another part of the project. And I import, again, I import NVD from tools. I'm not importing the download because in this section, I'm not downloading anything. And I download the entire data module. I'll be using all of its functions. Now, for everything that we'll do, we have a few data frames. And the approach here is to create this global dictionary, DF, uppercase, and store the data frames that we need in there. So right here, let me go to this. Let me start. Okay. So notice here that I'm only declaring a function, defining a function to prepare the data, which really there are just two data frames, geographic data frame and data by year that I define later in the notebook. But I'm not calling this function. And this is intended, you see, this goes to NVD module. So it goes into my analysis module later that I can, in the dashboard, I can import it or anywhere. Actually, just this example in my slides, right? So here, I import analysis, and the first thing I need to do for things to work is to create all the data frames. You can just call this, add this line to a module. So every time the module is imported, the data would be created. Again, this I don't recommend doing because as the data, you want your imports as fast as possible. So define the functions, but don't try not to do too much work inside of these functions, and make all the work explicit calls to, like here, prepare data. So I don't know if I ran it. Yeah. Now for interactive work like here, we're executing the cell. So we're populating this global object with data frames. Data by year, really, we just take the employment and population data frames and merge them together using state and county codes and years, and drop all the missing values to make our life simpler here. And this is how the final analysis data frame looks like. State, county code, year, total population, and population growth, employment and employment growth. These are percentage growth year over year. Let's explore the data a little bit. And well, I was planning to do a short live coding session. I will do it anyway, even though we don't have that much time, but just to demonstrate the typical workflow. So I have my DF by year, or how do I call it? I have a cheat in a separate notebook, but I'm honestly doing it live. Okay, yeah, so that's the data frame. Let's grab it in a temporary table and make it copy so we don't mess it up. And for example, we want state equal to 0. So this is the code for the entire economy. So okay, so just the national employment and population. That looks right. We can use year for the index. We'll make the plotting easier. Okay, so again, making sure this is why I'm doing this is not to teach you data analysis with Python and pandas, but rather just show how my own typical analysis workflow looks like. So I'm starting with this quick and dirty short and bed variable names, no documentation. But again, this is Scratch code that I just need for exploration, so that's fine. Okay, the data frame looks right. Let's visualize this. Let's look at the population. No, that doesn't look good. Why? This happens all the time. Well, yeah, it's not really what I wanted. Why? Oh, yeah, of course. That. Okay, yeah, so this is US population over time. And actually, we saw this line before. Good. And we can also throw in employment. Okay, so we have population employment lines. They are in total number of people. So we cannot really say, for example, which was growing faster, which was slower, but that's a good start. Let's keep that cell as it is for reference. Now let's maybe let's normalize this series a little. So we have the growth rates. So we can do, let me just make a copy. So D for employment, we'll take the growth rate. It's in percentage terms, so we need to divide it and add a 1. And do a cumulative product. So how does it look? Looks about right. Yeah, this is a terrible name for a column, but this is just playing around. Let's see how it works. Okay, so now it's normalized. That is, in the first year of data is 1, well, almost really. It's not precisely, but almost. And it goes like this. So we can repeat this with population. So we can put them side by side. We'll put them on the same graph and see which was actually growing faster. All right. So the employment, which is we plot first, so it's the blue one, and we've actually seen this shape before. It grows faster than population in the 90s, then a little recession here, then a bigger recession in 2008, 2009, a big drop in employment, and then the recovery in the past decade. So that all makes sense for an economist. And population is steadily growing, except for this odd jump that you remember. But so this is where I typically start. Once it starts taking shape, the code starts taking shape. I like the results that I'm getting, or some of the processing. I compute some useful variables, and I say, okay, it's good enough. Then I usually wrap it in a function, so I can avoid. Well, you see, I've thrown around this df. Then I make a d, another variable. Maybe inside of some functions, I use d or df. This is, again, this global variable problem. But in the end, it's all wrapped in a function, and all these variables are hidden. All the processing happens in a function namespace. So below, again, what I've made here, I can save. I can keep for later. It will be in a notebook. I don't need it in the documentation. I don't need it in the production code. But later, if I go back and try some other ideas, this could be a good starting point. Just some little sandbox. So I see, okay, this looks interesting. Maybe I can look at different states at different years. So it's all wrapped into this biggish function. Actually, you would probably want to break it into multiple ones. First, prepare the data, and then do the plotting. But this one prepares the data and produces a matplotlib figure. All right. So it's a function that takes state code, county code, and years as parameters. Now we just have a decade around the Great Recession. It is in solid lines. It's plotting employment and population in Wisconsin. Dotted lines plot United States. So you can see from this panel that, okay, population was in Wisconsin was growing slower, and employment was in Wisconsin was also growing slower than in the United States over these 10 years. And the little bar chart. Again, why do we want a function? First, to avoid all this little variables problem, because you see I have A, fig, x. So all this, I'm using all these variables, but they are wrapped, nicely wrapped in a function. I even have a nested function inside of it. It all exists inside, and I don't need to worry about overwriting some other variable, as long as my function name is meaningful and doesn't collide with other parts of the module. And also, so here, going back to my slides, I'm using this function, so I can use it in different parts. I can quickly make multiple plots. For example, I can put a day and county here. I memorized. These are, trust me, these are the only two codes that I remember by heart. Well, except for Alabama, which is 01, and some county that starts with A, which is 001 in Alabama. But yeah, so passing the county code other than 000 makes a plot for the Dane County, with and the dotted lines here are now the state as a reference. So Dane County was growing faster, both in employment and population terms than the state. So I can quickly produce these different charts for a report, for example. Okay. Let me try to finish this in 10-15 minutes. And I will give Lane a bit of time to wrap up the workshop. Now, well, if you start here, you have this function that can do useful things for different input parameters. I can change years to, I can look at maybe the last 10 years available data. So it's all growing, no major drops. Right before COVID, it looks different in the last 2 years. So now I have this function, and if you do it again and again, I think, oh, it would be cool if I could pick the state with the interactive drop-down button, or I could pick a year with the slider. So enter Jupyter Widgets. This is the tool that you can use. Here, I will just fly through this quick introduction to widgets. Basically, widgets, when you approach them, I suggest to think of them as just like Python objects, like strings, lists, pandas, data frames with state and some useful methods. And again, this is a figure, this is another object. Then a table is a data frame. And when you run it in a notebook, you get the representation of that object. For the figure, it's just this raster image. For a widget, every widget has its own representation. Here I make an integer slider, so can go up and down. The difference, of course, is that it is interactive and it stores the state. So I can then go at W value. So W is my widget now. It exists in the global space. So I can call it and it says 6. I can change it and it says 3. All right. But I can also change the value in code and see the slider jump back. Let me repeat this. So it's now at 10. I can call this in the code and the slider jump back to 5. Make sure that's the value now. We can, of course, combine multiple widgets. We can even use LaTeX for to make them look, the text labels look better. So here I have two in sliders for numbers X and Y, a button and a label. So it's a tiny little calculator that adds up to numbers. Now there's a function that takes X and Y and, well, returns a sum. We use this function. Again, think of it when you're building a project, this can be a function that produces a plot, for example. Then we need a handler function that will be called every time a button is clicked. So this function will read the values from other widgets, will compute the result, and change the value of the label. So this, well, if I change the sliders, click the button, the X and Y changed. The answer is also always a 5. So this is a more realistic and useful example where I create 2 dropdowns for state and county selectors. And the cool part about them is So let me just do this real fast demonstration. So when these two widgets are put together, inside of the function, I'm hiding some logic where the two widgets are actually connected. And of course, the list of county names is changing from state to state. So right now, there's nothing because it's the United States. But if you pick our favorite state, we got the list of counties updated dynamically. Well, see, Adams, Ashland, Barron. Now pick a different state. The counties are different. And what's happening is that inside of this function, the value of the state selector is used to update the options for the county selector, and we're using these global data frames to pull the data from, like the names, the state and county names. Let's combine a few widgets. A slider for years, selector for the geographic area, and there's a button here. And this is, again, I'm just calling this plot growth function that I defined above. So I can say, all right, how did it look around the .com bubble, for instance? And in the state of California. Okay, this will just give me the result for the entire state. Okay, well, there's a little dip in the employment. Actually, if you look at the bar chart, it's a -3.5% drop in the employment, and then it went up again. We can look. Other than Dane County, I don't know much about U.S. geography. You know what this is, but here's something else. Okay, it works. Again, you see that California is a reference. If we make a state plot, the United States is a reference. So all these labels of plots are dynamically updated inside of the plotting function. Now, we've played with this. Again, this is maybe not necessarily for presentation. Of course, you can make a dashboard out of it, but this is for you to look around and actually think about your research question. Now, okay, different areas look differently. So maybe we can compare them. Compare growth rates in Wisconsin and California and Alabama. So here comes that. There's another function that is computing the average growth rate between 2 years, Y0, Y1. It's taking, again, this global data frame. Some processing, calculation, and also puts the growth rates in four bins: pop plus, amp plus. So everything is growing, pop minus, amp minus, everything is declining. So we have these 4 groups. And actually, we will be using 4 colors to plot these 4 different classes, and a little function to create a color column. So compute AGR, average growth rate between 2000 and 2010. Again, state, county code, no years because it's average between the selected years. Total population. Oh, sorry, the absolute growth rate in percentage points. The reference, which will be, again, the U.S. growth for states and state growth for counties. Then I also have rel and abs, so relative and absolute. Actually, don't see. Oh yeah, here I'm calling for to use the absolute, but relative growth is compared to the reference. So U.S. relative to itself, the relative growth is 0. Okay, and then these are absolute and relative categories, and then coloring that we use later in plots. So yep, here comes the function. Again, very similar in spirit to the one that I was using before for dynamics, but now it's making a scatter plot. It takes a state and start year and end year, and whether we want the absolute growths or relative growths. And makes it a scatter plot. So here are average growth rate in Wisconsin counties relative to the Wisconsin state. So in the middle, 0, 0 is the average growth rate of the Wisconsin state, population on the horizontal, employment on the vertical. And then you have this bunch of counties here that were growing faster than average than the state, the counties that were growing slower, and the off diagonals. So population goes up, but employment goes down. Employment goes up, but population goes down. When you start working with data like this, very quickly you start thinking, oh, I wish I had a map. Of course, you can put little labels next to the dots, although with many counties, it might get a bit crowded. But this is where you start feeling itchy to actually make a map. And that's what happened with me. I learned a bit of map plotting, GIS tools and libraries. Oh, but before that, of course, the widgets. Yeah, so we can do the same change. So this, again, the United States, absolute, everything was more or less growing, but this dotted intersection is the reference. So if you switch to relative, these are the states. Some were growing, some were declining, and there was these all diagonals. So yes, but if we could make a map. So this is really the last tool that I'll introduce you to. And this is IPy Leaflet Library, which is a Python wrapper around a bigger and popular JavaScript library, Leaflet.js. And here, in a nutshell, the IPy Leaflet will give you a widget. Okay, we've played with the widgets above, so you will just get an IPython Jupyter widget when you use it. But because there is we want some functionality, we want to change the map a little bit, so it made sense to wrap it in a little class here, class called map, and it goes into a module, so I can import it in my dashboard in a second. Again, here's the core is that I'm leaflet.map. I'm making a widget. You can use different base layers. You can customize the map, look and feel of the map. Again, the link is here. Check out the examples and the documentation. But in the end, I create an instance of this map class, and I'm exposing this update function, which will take a state and years and relative. So it's like that scatter plot above, but now with a map. So I make an update to show 0, 0. So this is all the states compared. And I end the cell with a widget, so it will display that in a cell output. So this is the state. Yeah, you can customize the behavior when you hover over different shapes. So the states are selected. You can zoom, pan, so it all works. Oh, and the coloring, yes. So the coloring here is using the data that we constructed and the colors that we defined in the function above. Again, these are all little pieces are coming together in these maps. So here, the orange is where everything was growing, population, employment. The purple is where both population and employment were declining on average. Again, we look from 2005 to 2015. And there are some states where it was somewhere in between. Another thing that we expose in this class is a click callback. This is what will happen if I click different areas in this widget, different parts of this widget. And I make a new function, print area ID. It takes the keyword arguments from the area that triggered the event. And it will just print state code, county code, and name of that shape. And I'm switching to, I'm calling update to switch to Wisconsin. So now only this area is highlighted. Let me zoom in a little. These are the counties and relative growth. So Dane was growing employment and population, but others like the Milwaukee County was growing employment and declining population. So I wonder what the county name is. So I can click that. I see no output, again, because it got gobbled in the log. There's a way to bring it out, and we'll do this in the dashboard. But you can also in Jupyter Lab, this little icon got highlighted. So if I call print, it doesn't go to the cell output, but because it's happening as a widget callback, it goes to this log. But it works. So I can finally learn some other counties. Well, I know the Door County. I've been told that I should go see that. It's right there, this peninsula. Okay, and this last bit is, again, turning this into analysis module from which we can import. All right, 1 minute, really, a dashboard. At the top, we use widgets. Then I import my analysis module, and I do this little trick here, change the directory so it works on Binder, for example, where I cannot easily, well, you can, but I'm not creating symbolic links to my package. So instead, I move off one level to the root of the project, so the import works, and I prepare data. Call this prep data. So now that it's in there, then I create a bunch of widgets, year, state selectors, a map. Where's that? Yeah, here. Analysis, the map, the class that I defined. I had this little bug in the, I think so that it all works, but the half of the map is shown in gray. So in your version, if you're running this, that's what might happen. All right, and this is the output. So this is the widget where we will be displaying the graph. So let me run this all. You can do this in a notebook, of course. So in the end, we're getting this this app layout with a left sidebar with some controls, right sidebar with a plot, and the middle section with the map. I can change, use my sliders. It doesn't fit. Pick a different state. Update. Right. So here comes Illinois, and where's Chicago there? Yeah, Chicago. Click on T, and so I can select, and this is the stats for the Cook County. So this is pretty much all. The last little cherry on top is the Voila package, that Voila library that allows you to run this notebook and just hide everything and only display the outputs. So if you have it installed in your environment, which again you will if you just brought the environment from the specification, you will have this little button in your Jupyter panel, which starts this notebook in a separate Voila process, and it runs it all. And you don't see any code, you only see the output, which is really the key is this interactive dashboard. And it works, the kernel works in the background. So it all looks the same. And of course, you can use the standard markdown cells to describe what this is. So this is, again, here I'm running it locally. It's the same dashboard. And in the repository, if you click on this dashboard link, it will take you to Binder. And if you're lucky, well, actually, it worked for me multiple times when I tried, but just the last hour before the workshop, it was really getting problematic. But again, clicking this link, people who landed in your repository page, they can just go there and play with what you've done. So I conclude here, and I'll stop sharing now. I don't know if you have any more time left for questions.
Yeah, we're right up on 4:30. So I'm just going to quickly do the wrap up slides, and then if you have a minute, maybe people can hang around for questions at the end.
Yeah, I have time. I hope this.
Okay, cool. So let me just quickly go through these wrap up slides. So thanks again for attending this afternoon's session, everyone from the Data and Communities Data Bazaar. Please give us feedback on the session. You can fill out the form linked here. grab a screenshot for that URL. I can put it up again later, or it can be put in the chat as well. Casey, if you could do that. Also sign up for the newsletter so you can get some more news about data science events and training on campus. You can find that at the datascience.wisc.edu hub page. And register for those upcoming sessions this week and next week. Thanks again for attending. And Anton said he could hang out for a minute to address any questions. Thank you, Anton, and thank you everyone for attending. That was awesome.
Thank you, Ian, and thank you, everyone. And last thing is, if you want to follow up, feel free to send me an email. The slide, it will be in the slides that I'll send to this repository. And of course, you can go to the repository and open an issue. If you have some feedback, I would really appreciate that.
Cool, thank you, Anton. I did have a quick question, maybe just to open up questions in general. We can go for a couple of minutes, perhaps. Let me start my video here. I think it's quite often, if you're, and many people have probably had this experience working in notebooks, where you do that scratch code and you build things out and things get a little bit messy, and then you have to put stuff into functions, and then at some point you think about trying to move those functions out into their own code. And your approach here really seems to smooth that over, which is pretty cool. Is there a case now where you consciously think, okay, now I need to move this into a separate code file, and you're not using this process, or do you find that this handles pretty much that whole thing?
No, so I was, when I started this approach, I wasn't sure if it's going to work, and for some time in the beginning I was using just the code from the notebook, and I was using some like Jupyter Magics to run the notebook or some other things. But then I started using it, I think the past couple of years in the RDC. It's a limited environment. I don't have much freedom of installing things there, but this little tool to select cells from the notebook, that's all I really need. And it worked pretty well. One thing is that you might want to edit the plain file. So actually before, I was, at some point I have this combination when I had a notebook where I kind of try things, but when they work, I would take a cell, take a code, and put it in a separate script file that I'm editing on the side. So this was my approach for some time. And yeah, this creates a disconnect, right? It's a disconnect from where you document and try things from where you actually use things. That brought a lot of problems often. But with this, yeah, it works pretty well. And I brought this up when you do some batch processing on a compute cluster, for example. Again, notebooks might not work really well for it, but scripts are great. So I've been using that, no problem. I'm building this importable modules that all work together, and then I set a job to the cluster. Only the scripts go there, and yeah, that's been working fine for me.
That's awesome. Cool. So it looked like everyone dropped out of the session apart from the organizers and you and Nancy. So Nancy, do you have
Nancy.
any questions?
No, I don't, but thank you very much.
Thank you.
Okay, cool. Well, in that case, I think let's wrap things up here. Thanks again, Anton. That was awesome. I really appreciate you putting that together. I learned a couple of things, and I'm probably going to give this tool a bit of a go.